Good afternoon, everyone. Welcome to TDX, and thank you for joining my session today. My name is Aditya, and I'm a developer advocate at Salesforce. And today, we are going to be talking about security best practices with Agentforce. Kind of an important topic, right? So before we start off with the topic, quick forward-looking statements. Please make all your purchasing decisions based on generally available information and not based on any forward-looking statements that I might make in today's presentation. All right. So Agentforce, I'm sure all of you have heard about it. But when you look at the architecture, where is it placed? It's not a new tool or a technology built on a brand new platform. It is built on top of the existing Salesforce platform, and it leverages the unified metadata layer. What it really means is that because it's built on the same Salesforce platform that all of you have been using for the past 20 years, it respects the existing platform access controls that you have in terms of security, whether it is profiles, permission sets, field level security, so on and so forth. So all of that comes baked into Agentforce. Now, that's not all. Agentforce comes up with its own security mechanisms that make sure it is secure for you and your customers, whether it is accessing data within Salesforce or whether it is for the prompts from Agentforce to go out to external LLMs. So there are a lot of security mechanisms that we have built into Agentforce. And as an admin, as a developer, you need to understand all of these thoroughly to be able to implement a secure agent. So I'm sure all of you are here to learn about that. And quick show of hands, how many of you have already built agents and put it on public for people to use? All right, cool. Not a lot of hands, which is good, because now you'll be starting from ground up with all the knowledge that you're going to need to build secure agents. So let's start off with the most basic ones that most of you should already be familiar with, which is platform access controls. And if you're working with Salesforce, you know that any access control is defined based on the user context. Who's the running user, and what permissions do they have? Now, when it comes to Agentforce, who's the running user? Who's the agent running as? And to whom should you be giving the permissions? So that's the first question that you should be answering. And for that, there are two kinds of running users depending on the type of agent that you're working with. Let's say you're working with an internal agent, that is Agentforce Default, SDR, Sales Coach, Agentforce for Setup that's coming out now. All of those run in the context of the user that is invoking the agent. That is, whoever is a logged in user that is invoking the agent, Agentforce is going to run in that user's context. So which is similar to everything in Salesforce. Let's say you're accessing a page, a record. It's all in the context of the user accessing that particular feature. But when it comes to an Agentforce service agent, which is an external-facing agent, it runs as its own dedicated user. And that user is called as an Einstein service agent user. It has a different license type. It has different permissions. So this is the first distinction that you need to know about. Who is the running user? For internal agents, it is the user invoking the agent. For external agents, it's always a dedicated user that is set up. Now, the thing with that dedicated user is you can share that user across different agents. So you can build any number of service agents that you want, up to a specified limit in your org. And each agent can have its own user, or you can have one Einstein service agent user working across all the agents. But as a best practice, we recommend you create one agent user per agent, primarily because you build different agents for different purposes, and you don't want the same level of access control spreading across all the different agents that you have. Now, the second point, the did you know, I wanted to call it out because when you talk about a dedicated user for a given feature, then when we try to build something like admins and developers, we run into access issues. Like we say, it's working for me as an admin, but once you deploy to an end user, it stops working. So how do you get around that? With flows, you have a run as user in order to debug and so on. What's cool about Agentforce is that the builder itself, in which you're building the agent, runs in that user context. So the Einstein service agent, if you're building it, it runs in the context of that user. So any issues that you would encounter in production After deploying it externally, you would actually run into them right inside the builder. So it's a handy little feature that you can use in order to ensure you're building your agent out properly. Now that you know who's the running user, what are the permissions that that running user must have? For example, let's talk about the internal agent. So the user that is running the agent, what permissions must they have? First and foremost, they need to be assigned the access Agentforce default agent. It's quite a mouthful, but there is one permission set that needs to be assigned to any user internally who needs access to Agentforce. Then you have two more permission sets for data cloud user and prompt template user. Like the name suggests, in case your agent is interacting with data cloud data, the running user needs to have that permission set to be able to access data cloud data. It's the same case with prompt templates. If your agent is invoking a prompt template, the running user must have access to this permission set, which is prompt template user. Now let's look at the service agent. Now this is for that dedicated user. So these are the permissions that you need to assign to that dedicated user. Now first and foremost, you have the, again, quite a mouthful, Agentforce service agent object access. So that's a shared permission set for all the different agent users that you might have, which is why you can only assign very few permissions in that permission set. Like if you go into the permission set detail page, you'll only be able to give access to contacts, knowledge, and cases at most. Now for all your different objects, there is a different permission set that you will have to use. And each time you create a service agent, there is automatically a permission set with the name of that agent created for you. For example, if I say TDX service agent, then there is a permission set called TDX service agent permissions that is created for that particular agent. Now that is completely open. You can define object access for any object that you want, standard, custom, platform features, system permissions, so on and so forth. All of that needs to be given. Now the permission set group that you have, it contains the same permission sets that we have seen before, like data cloud user, prompt template user, and so on. But again, the good thing here is whenever you create that new service agent user, by default, we automatically assign these permission sets to that user. So you don't have to manually go and do stuff. So that's something that happens. So next, you know who the running user is. You know what are the default permissions that you need to give that running user. But what about additional permissions? Now remember that dedicated permission set that gets created for every agent. What access do you need to give? So bare minimum, you need CRUD and FLS on any object that the agent will work with. Now it's important to remember that it is not just about giving CRUD and FLS for the objects that it will directly use. Even if it invokes an Apex class or a flow, which in turn use some objects, you need to give access to those objects as well. So it's not direct access, any indirect access as well, you need to be giving those permissions. You'll see a few examples in coming slides, but that's very important to remember. Second one, of course, is to give access to relevant records. Now, as I mentioned before, you can use any of the existing platform features like sharing rules, sharing sets, so on and so forth. It's up to you. It's your implementation. You can do it in whichever way you want. But the only caveat here is that the permission set that gets assigned to this agent users does not have the view all permission. So you can't just say this agent can view all the records. You need to come up with your own approach to share records with that particular user. Whether you want to define a checkbox that says share with agent or a checkbox that says do not share with agent, that is up to you. But what we anticipate is you'll end up creating criteria-based sharing rules. So that's how you're supposed to share all this data with that dedicated agent user. Now we are talking specifically only about service agent because for an internal agent, it anyways respects all the internal user permissions, which you would have already defined because your implementations go way back before Agentforce. Now as a best practice, share only the data that the agent needs. Principle of least privilege, all of us know about it. The second best practice that personally I would suggest is that do not take and place your Einstein agent user on top of the role hierarchy. Now, that's a very good workaround if you want to open up access to all the records, but very rarely you would give access to all the records to an agent because agents are external facing. I don't think they would need that level of access. So take care, do not bypass all the sharing rules by putting it on top of the role hierarchy. Now, of course, you need access to the relevant Apex classes that the agent is going to need. You're going to need access to the relevant data spaces for the agent. And flows and Apex run in the context that they are created to run in. Now, this is important because you can give access to an Apex class, but the Apex class itself can run either in with sharing mode or without sharing mode. The queries that you write can run in user mode or system mode. Same goes with flows. So when you create a flow, there are 3 options that you can give. It runs in user context, system context with sharing, system context without sharing. So there's a lot going on. Those are respected because in the end, like I said, whatever you define in those components, stay with those components. Now, common errors. So that was a lot of text. These are a few examples that I personally ran into when creating the agents. So I thought I'll put it on the slides. So first and foremost, what I've done is I've created an Apex action. I've put it on the agent, and I was trying to invoke that particular action. And then I realized in the planner, I could see that my agent action itself was not getting recognized. So I tried figuring out a bunch of different options, and eventually I realized that the agent user must be given access to the Apex class. So without access to the Apex class, the corresponding action is not even recognized by the agent. So that's how it works. So let's say you get around that, you give access to the Apex class, and then you run into this issue where the action gets invoked, but then it fails with a permissions issue. Now, all of you can guess, this is going to be a CRUD issue because it clearly says that it's not able to see a particular field. So you end up giving read access. Or you will run the query in system mode, which is not something that we generally recommend. But if you want, you can do that as well. Now, let's look at a different example. And this time, we are using a flow. And in the flow, we are running the flow in the user context. The OWD is set to public read only, which means the flow should be able to access all the records. But then it still is not able to access the records. And why is that? So this is also a CRUD issue. Agent must be given read access to the object. So if any permission is missing, then you are going to run into errors. So despite your flow being run in any mode, you're going to see the same kind of errors. That is what I try to show in the next screen. Let's say you ran into that error, so you decide, yes, let me change my flow to run into system mode, and hopefully that will solve my error. But as you see, there is no error, but the data that is coming back, it doesn't show all the details that I want. It just shows the product ID. Why is that? Is because your agent doesn't still have read access to that object. So despite your flow running in that system mode with access to all the records, bare minimum read access on objects is necessary for you to be able to see all the fields of a given object. So these are some common errors that I personally ran into, so I've just put it on there. Now, a few things to remember. Flows and Apex classes, we can't stress this enough. Run it in system mode only when appropriate. Don't think of it like a foolproof solution to bypass all the errors that you have. And the other important, very important point, in fact, to remember is that whenever you define sharing rules, OWD, and all of those are only applicable on Salesforce data. Now, let's say the Salesforce data gets ingested into Data Cloud. What happens is all this data goes into data lake objects and data model objects, which do not respect the same sharing permissions. Access controls in Data Cloud differ based on the data spaces, which is a completely different concept. So you need to remember, if you are accessing data from Data Cloud, it doesn't respect the sharing rules that you necessarily have for the same data inside Salesforce. So that's a clear distinction that you need to keep in mind before working with Data Cloud. And a quick tip, all of you know about this. If you want to debug a flow that is running as a specific user, there is provision for that. So if you run into issues like I've shown you in the previous slides, debug the flow as that Einstein service agent user, and hopefully you'll find the error for that. Now, moving on to the next segment, we were talking about platform access controls, which is something that all of you have a fairly good idea about. Now, Agentforce guardrails is something of a security mechanism that we add specifically to Agentforce. And what does it contain? At the very basic level, it's going to have the trust layer be a major part of the security that we provide to Agentforce. So anything that Agentforce does converts into a prompt, and the prompt goes out to an LLM, and it goes through the trust layer, which provides a bunch of guardrails like data masking, toxicity detection, about which I'm not going to go deeper because I've done a previous session on that. You can find that recording. But generally speaking, there is a lot going on in the Einstein trust layer to safeguard your prompts when going to the LLM. So that's all internal. We take care of that. Now, what is in your control? What is the next level of security that you can define on your Agentforce agents? That is topics and instructions. So these are going to be the guardrails for your agent in order to define what your agent can do, what your agent should do, and what your agent should not do. So you have to be very prescriptive with the instructions about, OK, this is your scope, do this, and do not do something else. Let's say, do not return a record ID back to the user. So that's something that you would say. And that's how it works out. Now, these topics are respected. For example, if you notice a bunch of screenshots that I've added, let's say the user asks a question that falls outside this topic. Then we automatically classify it as off topic, and we don't answer that question. So in a way that you're securing your agent to only answer a few questions. Now, let's say there are some malicious users out there who want to tamper with your agent. Now, just like you have JavaScript injection, you have what we call prompt injection. So we take care of preventing prompt injection attacks as well. If somebody tries to do that, we automatically classify it as prompt injection, and we stop it right there. So there's a lot of standard topics that we classify your prompts into to ensure your prompts are secure. But then, depending on your business use case, you'll have to create your own topics and own instructions. Now, the third important piece of any agent, topics, instructions, and finally coming to actions. So actions can be classified into two ways. One is a public action, and the other one is a private action. Now, unlike your Apex classes, this is not a setting that you define on any action. It's just a conceptual classification based on how the action behaves. So there is no setting. It's just behavioral classification. To give you an example, let's take public actions. So these are actions that can run on behalf of anyone. You don't need to identify who the user is. For example, if it is an FAQ, it doesn't matter if you're asking or you're asking. It's the same FAQ. And I don't need to validate who you are as well, because I'll return the same response back. So these are public actions. Now, what you also have is private actions. So contrasting to public actions is that you first need to validate who the customer is before even invoking this action. Now, why do you need to do that? It's for security purposes. Let's say I have an action that returns a list of orders. Now, if I ask, give me the orders, it's going to ask of whom. I'll say my email address, and it gives me my orders. Now, if I know the email address of you, and if I give your email address, I'll get your orders as well, which is a major security flaw. So private actions need to be dealt in a slightly different way. So how do you identify how to secure those private actions? How do you know who's invoking? How do you validate the identity of who's invoking? Like if I give an email address, you need to verify that it in fact belongs to me. So how do you do that? For that, we have new trust features that if you watch the keynote, we've already announced in there, which are called agent variables, action bindings, and filtering rules. So essentially talking about agent variables, these are private variables that are present inside every agent. And these private variables can only be set by the actions themselves. So you cannot set these values externally, and nobody can tamper with them. It's only an action that will be able to set the value of these private variables. And then we have action bindings. So what do you do with these variables? You use these variables to pass in information from one action to the other. So let's say, I'm going to show you a quick example that makes it much more clear. So let's say you have an action that validates an email address. So I put in my email address, it's going to validate it, which means it will run an action to query a particular contact. And then that contact ID is passed in to retrieve my orders. So how is the contact ID of one method being passed as an input to another method? So right now, agent has that capability, and it completely relies on instructions, which is not completely secure because I can tamper with those instructions. I can have a prompt very cleverly crafted that it will pass in the contact ID that I want. So to prevent that, you're going to assign that contact ID to a variable, and that variable is bound to the other action. In the demo, it will become much more clear. And finally, you have filtering rules. So now that you have these private variables, you can even go on till the extent of saying, if the value of this variable is this, only then invoke this action, or only then invoke this particular topic. So it's a way of you defining that, let's say you haven't given the email address, then the contact ID private variable is going to be empty. Then you can define a filtering rule saying, if this variable is empty, don't even invoke the action. So that's something that you're defining explicitly using these variables, instead of just writing random instructions and praying to God that it will work. Okay? So let's look at a very small demo to see how it really looks. Now, what we are shipping out is also a standard topic called customer verification. So this topic will take care of a two-factor authentication. That ensures you give your email address, there is an OTP sent to that email address, and you get back that OTP, put it in the chat. So that's a secure implementation, two-factor authentication, and that's something that we are shipping out of the box using the standard topic. Now, within this topic, what you will see is, it should be familiar. It's a bunch of instructions, and then you have actions. So for example, here we have the first action, which will send an email with the verification code. Now, what is new here are variables. So this action takes in an input, which is the email address to verify, and the output is going to be a bunch of fields. Now, what you can do is you can bind this particular output to a variable. So right within this wizard, you can create a custom variable. This is going to be a private variable for that particular Agentforce session. So here I already have created a bunch of variables, so you can assign this variable to assign this output to that particular variable. Now what you do is, for the second action, you can bind the same variable as an input. So you define variables, assign the output of one action to that variable, use the same variable as an input to the other action. So this way, you are absolutely certain that the data will pass in the way you want, instead of relying on instructions. Now, all the variables you can find in the context. So previously, it was just the context variables that you have. Now you have access to all the custom variables as well. Now, what you can also do, I mentioned action binding, I mentioned variables, and the third piece I mentioned was filters. So here you can define a filter. So let's say you create new, you give it a name. It's basically like a flow. You're used to defining these filter conditions everywhere in Salesforce, like list views, flows, and so on. So you explicitly say, OK, if customer ID is empty, then you define this filter. And this filter is something that you can go back and assign to your actions. Now, for example, I go back. I have an action that retrieves my orders. So if I go to the action, I click on Get Recent Orders, you will see a filter icon on the top. So if you click that, you can assign a particular filter to that action to say only if this value is populated, this action should be executed. So that way, you're really cutting down the entire guesswork out of the way and making sure these actions are executed only if those conditions are met. Now, if you try to execute this, this is how it's going to look like. So let's say you say, get me my orders. Then it's immediately going to invoke the customer verification topic. And it's going to say, before I can help with that, give me your email address. So you give your email address, and then it's going to send out an email. Then it says, provide the verification code, which is then going to be, again, invoked by the customer verification itself. And once it has identified you as a customer, so here you can see that is verified is now set to true, which means now it can execute that get orders action. So now if I ask the same question, get my orders, it's able to get my orders. So this is how a secure implementation looks like. And this is how all of you are supposed to do it going forward. Do not rely on instructions. Rely on these variables. Now, quickly wrapping up, there are multiple ways in which you can establish user identity. Take a picture. We'll also share these slides. But just know that whatever you do, it is important that you set the value of variables and only use those variables in your subsequent actions. Do not directly rely on any other mechanisms like you have, even if you know who the authenticated user is. I've seen some implementations where you use pre-chat variables and stuff to pass in information. So even if you do that, we are expecting you to still revalidate all that information inside your agent by means of these variables. Because any action should only take in a private variable as an input if you're dealing with customer-sensitive data. Do not rely on data coming in externally from either your Experience Cloud website or a different website. Do not rely on that. Use it, revalidate it, put that trusted value into a variable, and use that variable into subsequent actions. So this is, at a very high level, how we are envisioning security with Agentforce to look like. And as you know, it's a very rapidly evolving product. So this is what it is right now. In future, if there are changes, then we will definitely let you know. And how can you stay tuned is that please subscribe to our YouTube channel or the developer blog. Not just me, all my advocates team, we put in a lot of content on YouTube about everything latest and greatest that is happening. So that's the best place I would recommend, because any link that I share might become outdated in a month or two. So this is the place to be. And I would like to wrap up with this. And thank you all. You've been a wonderful audience, and hope to see you in a different session. Have a wonderful time at TDX.